Okay, now we're going to take the concept of the square root and we're going to expand that out to talk about what we call the nth root. Okay, so a number b is an nth root of a if when you multiply b by itself n times, you get a. Okay, so instead of just the square root where you multiply b by itself once, right? So you have b times b. It might be for a fourth root, it would be b times b times b times b is going to equal a. Okay, so the way that we designate the nth root, okay, is by going ahead, okay, and what we do is in our radical, we put the number of the root that we're taking. And this number that we put kind of here in what I call the crook of the house, we call this the index, okay, of our root that we're taking. So a square root has an index of 2, a fifth root has an index of 5, and so on. Okay, so if you don't see a number in the crook, it's assumed to be a square root. Okay, for anything larger than a square root, you're going to see a number there in the index. All right, so when we look at the rules for nth roots, looking in general, okay, we have to split up into two possibilities. One is if n is an even integer, and the other is when n is an odd integer. So if n is an even integer, okay, this is going to be a lot like the square root is. Okay, all right. So the big thing is that you need to keep in mind is that if you're going to take an even root, you have to take an even root of a positive number. Okay, just like you can't take the square root of a negative number, you can't take an even root, you can't take a fourth root or an eighth root of a number that's less than 0. Okay, so when you do that, though, so if you have a positive number that you're taking an even root of, okay, then if I want the positive root, then I just write it with the radical and the index. If I want the negative root of that number, then I'm going to put a negative out in front. Now then, if n is an odd integer, things are a little different, but in some ways they're a lot easier. If n is an odd integer, okay, the nth root of a is just the nth root. There is only one odd root for every number. Okay, so you can always take an odd root of a number, positive, negative, otherwise, okay, and there will only be one answer. Okay, and then of course the nth root of 0 is just going to be 0. All right, so let me kind of summarize what this means when you take when we take an even root versus an odd root. So, all right. So for an even root, okay, you have to have a positive number. Okay, you can only take the even root of a positive number. Right? Whereas on an odd root, you can use any number. All right. When you take an even root, where you can take where you can actually take the root, so you have your positive number, then you have two roots possible. Okay, one positive, one negative. Okay, when you take an odd root of any number, okay, you only have one root, all right, and its sign matches the sign of your original number. So if you're taking the odd root of a negative number, you're going to get an odd number for your solution. If you take the odd root of a positive number, you're going to get a positive number out of there. Okay, so, and then also for even roots, it said negative numbers, okay, have no real roots in this case. Whereas for odd roots, okay, yeah, negative numbers do have a root. Okay, so with this information in mind, let's take a look at a couple of examples here. So we're going to simplify these radicals right here. So for the first one, I'm going to take the cube root of 64. Now then, keep in mind, I'm taking the cube root, so my index is 3. That tells me I want an odd, I'm taking an odd root. Okay, because I'm taking an odd root, I know I only have one root possible. Okay, and I know that it's going to be positive because 64 is positive. All right, well, the way I'm going to find that is I'm going to take 64 and I'm going to start factoring it. Well, I know that 64, that's 4 times 16, and 16 is 4 times 4. Okay. So I can see here, okay, that 64 is equal to 4 cubed. So my answer for this first one is 4. Okay. Now then, taking a look, now I have the fourth root of 81. Okay. I am taking an even root. Okay, that means that I have to make sure, okay, 81 is positive, so I know I can take that root. Okay, so there are 2 possible roots. But because I don't have a negative out in front, I know I want the positive root. Okay. So when I take a look at 81 and factoring that out, I get 9 times 9, and 9 is 3 times 3. Okay. So sure enough, 81 is equal to 3 to the 4th power. Okay, which is what I want for my answer. Okay. So, all right. Okay, for the next one, I have the 5th root of negative 32. Okay, so notice I have a negative under my radical, but I am taking an odd root. So I know for an odd root, I only have one root. Okay. And it's going to be negative because the square root of 32 is negative. All right. So what I'm going to do is I'm just going to go ahead, I'm going to factor 32. Okay. And then I know that my answer has to be negative and I can do it that way. So 32 is 2 times 16. 16 is 2 times 8. 8 is 2 times 4. And 4 is 2 times 2. So notice I've got 1, 2, 3, 4, 5. Okay. So I know that negative 2 to the 5th power is going to equal to negative 32. So my answer for this one is negative 2. All right. And then lastly, I'm taking the 4th root of negative 16. Now then, I am taking the 4th root, which is an even root. So I need a positive, number. Okay, but negative 16 is not positive. Okay, so this one has no real solution.